Why are there not more people talking about how a cloud of cosmic dust became the vibrant, life-filled Earth we know today? Our story begins in darkness with a vast cloud of gas and dust, the solar nebula, drifting through space. This nebula was a remnant of previous generations of stars, containing all the elements needed to create new worlds. A nearby star exploded in a supernova, sending a shockwave that compressed the nebula and set gravity into motion. This powerful event triggered the birth of our solar system. The cloud collapsed, spun faster, and flattened into a disk. This spinning disk, known as the protoplanetary disk, was the cradle of our solar system. At its center, pressure and heat soared until hydrogen atoms fused, igniting our sun. This nuclear fusion marked the birth of our star, providing the energy needed for the formation of planets. The sun's birth illuminated the disk, and the remaining material began to form planets. Dust and gas started to coalesce, creating the building blocks of our solar system. Close to the sun, only rocky materials survived, clumping together to form Mercury, Venus, Earth, and Mars. These inner planets are small but dense, made mostly of metal and rock. Farther out, ices and gases allowed giant planets, Jupiter, Saturn, Uranus, and Neptune, to form. These gas giants are massive, with thick atmospheres of hydrogen and helium. Each planet grew from countless collisions and mergers, sweeping up material in their orbits. These violent impacts were crucial in shaping the planets we know today. In time, a family of planets, moons, and smaller bodies emerged, all orbiting our new star. This diverse collection of celestial objects forms the solar system we call home. From a cloud of stardust, our solar system was born. This cosmic journey from chaos to order gave rise to the planets, moons, and the sun, creating the dynamic system we observe today. 4.5 billion years ago, Earth was a molten, hostile world, its surface a churning sea of lava and fire. Asteroids and comets bombarded the young planet relentlessly, shaping its landscape through violent collisions and constant upheaval. The air was thick with toxic gases, and the environment was far too extreme for any form of life to exist. As these impacts continued, heavy elements like iron and nickel sank deep into the planet, forming a dense, metallic core. Meanwhile, lighter materials floated upward, creating the rocky crust and the mantle that would one day support continents and oceans. This internal layering was crucial for Earth's future magnetic field and geological activity. In this chaotic and crowded solar system, a Mars-sized protoplanet named Theia was on a collision course with Earth. Their fateful encounter would change both worlds forever. The colossal impact not only tilted Earth's axis but also blasted an immense cloud of molten rock and vaporized material into orbit around the battered planet. This glowing ring of debris swirling high above the surface was gradually pulled together by gravity. Over time, these fragments coalesced, cooling and solidifying to form what would become our moon. The moon's birth was more than just a spectacular event. It stabilized Earth's tilt, preventing wild swings and giving rise to regular seasons and a more predictable climate. The moon's powerful gravitational pull also slowed and steadied Earth's rotation, reducing extreme climate variations and helping to create a more stable environment for life to eventually flourish. Today, scientists find striking similarities between rocks on the moon and those on Earth, clear evidence of their shared, violent origin in that ancient collision. This dramatic event set the stage for Earth to cool, develop a stable crust, and eventually become a planet capable of supporting oceans, continents, and life itself. The moon's presence would shape the tides, influence the length of days, and light up the night sky, playing a vital role in the evolution of life on our planet. The violent birth of the moon was a turning point in Earth's story, marking the beginning of a new chapter that would ultimately lead to the world we know today. After the moon-forming impact, Earth began to cool, forming a fragile crust over a molten mantle. For millions of years, asteroids and comets bombarded the planet, delivering water and organic molecules. Water vapor thickened the atmosphere, eventually condensing into relentless, planet-wide rain. Torrential rains filled basins and craters, forming the first oceans, hot, mineral-rich, and greenish from dissolved iron. Oceans began to regulate Earth's temperature and dissolve minerals, creating a stable environment. The atmosphere was toxic and lacked oxygen, but liquid water was now abundant. These oceans became the cradle for the chemistry of life. With water, minerals, and energy, Earth was ready for the next step. The stage was set for life to begin. Life's origins likely began deep beneath the ocean, far from the sun's harsh rays. Hydrothermal vents on the seafloor spewed hot, mineral-rich water, creating unique chemical environments. Here, simple organic molecules combined and evolved into self-replicating structures. The first life forms were single-celled microbes, prokaryotes, thriving on chemical energy, not sunlight. These chemotrophs consumed minerals from the vents, fueling their simple metabolisms. For hundreds of millions of years, these microbes dominated, hidden in the ocean's darkness. They were the ancestors of all life, quietly shaping their environment. Microbes spread across the ocean floor, adapting to extreme conditions. The surface remained barren, but the oceans teemed with microscopic life. Life had begun, small and unseen, but unstoppable. For over 1 billion years, life remained simple, until cyanobacteria evolved a new trick: photosynthesis. Harnessing sunlight, they produced oxygen as a byproduct, transforming the oceans and atmosphere. At first, oxygen reacted with dissolved iron, creating vast iron ore deposits. Once the iron was gone, oxygen began to accumulate in the atmosphere. This great oxidation event was catastrophic for anaerobic life, causing a mass extinction. Yet some microbes adapted, using oxygen for respiration, a more efficient way to generate energy. Oxygen also formed the ozone layer, shielding Earth from harmful UV radiation. The surface became safe for life to expand. Oxygen's rise set the stage for complex life. Earth's climate remained wildly unstable, with powerful tectonic shifts and relentless volcanic eruptions constantly altering the atmosphere. The planet was a place of chaos, with continents drifting, mountains rising, and the sky often darkened by ash and gases. These dramatic forces shaped the world in ways that would have lasting consequences for all life. Acid rain, formed from volcanic gases, fell relentlessly on the barren rocks. This weathering process pulled carbon dioxide from the air, slowly but steadily reducing greenhouse gases and triggering a dramatic global cooling. The planet's surface became even more inhospitable as storms battered the land, stripping away soil and minerals. As carbon dioxide levels dropped, ice began to spread from the poles, reflecting sunlight and plunging Earth into a deep freeze, an event known as Snowball Earth. The entire planet, from pole to equator, was soon locked in a frozen grip, with only a few areas escaping the ice. Oceans and land alike were buried under thick, impenetrable ice sheets, stretching for thousands of kilometers. This icy prison threatened to wipe out nearly all life, cutting off sunlight and isolating ecosystems beneath the frozen surface. Yet, against all odds, life endured. Tiny organisms found refuge in the warmth near volcanic vents, and in cracks where the ice was thin enough for liquid water to persist. These hidden sanctuaries became lifelines for survival. Extreme conditions drove rapid evolution and innovation. Life forms adapted to the darkness, cold, and scarcity, developing new ways to survive in the harshest environments Earth had ever seen. Meanwhile, volcanoes continued to erupt beneath the ice, releasing carbon dioxide back into the atmosphere. Over millions of years, these emissions slowly built up, eventually reaching a tipping point that would change everything. As the greenhouse effect returned, the ice began to melt. Massive floods released trapped nutrients into the oceans, transforming them into fertile grounds for new life to flourish. Survivors emerged from their icy refuges into a world transformed, one ready for new beginnings and the rise of more complex life. The end of Snowball Earth set the stage for an explosion of diversity, as life rapidly evolved to fill the newly available niches. With the planet thawed and conditions improving, life was about to take its next great leap, ushering in a new era of evolution and possibility. With the ice gone and oceans rich in nutrients, life exploded in diversity, the Cambrian explosion. Complex animals with shells, skeletons, and eyes appeared, filling the seas with predators and prey. Evolution accelerated as creatures adapted to new challenges and opportunities. On land, the ozone layer made the surface safe for life. The first land plants, simple mosses and liverworts, began to colonize damp rocks. Plants broke down rock, created soil, and pumped oxygen into the air. Over millions of years, vascular plants evolved, leading to the first forests. These forests transformed the land and atmosphere, paving the way for animals. The green invasion of land was underway. Life was no longer confined to the seas. Lush forests and oxygen-rich air drew animals onto land, first arthropods, then amphibians, and finally reptiles. Reptiles evolved into dinosaurs, dominating Earth for over 150 million years. Dinosaurs diversified into giants like Brachiosaurus, armored Stegosaurus, and fierce predators like T-Rex. Pangaea's breakup created new habitats, fueling even more diversity. But 66 million years ago, a massive asteroid struck Earth, unleashing devastation. The impact triggered earthquakes, tsunamis, and a global winter. Sunlight was blocked, plants died, and the food chain collapsed. Dinosaurs and 3/4 of all species vanished in the aftermath. The age of dinosaurs ended in catastrophe. Yet, extinction cleared the way for new life to rise. The world was ready for a new chapter. In the dinosaur's shadow, mammals had survived as small, adaptable creatures. After the extinction, mammals rapidly diversified, filling empty ecological niches. Some became large herbivores and predators, others returned to the water or took to the air. In Africa, primates evolved grasping hands and keen eyesight for life in the trees. As forests gave way to grasslands, some primates adapted to walking upright, our earliest ancestors. Upright posture freed their hands for tools and carrying food. Early humans learned to cooperate, hunt, and share resources. Over time, their brains grew, and they spread across the globe. Mastery of fire, tools, art, and language followed. Communities formed, knowledge was shared, and culture blossomed. From stardust to civilization, humanity's journey had truly begun.